Nervos Network is an open-source smart contract platform composed of multiple different blockchain layers that are specialized for different functions. In previous videos, we have discussed this modular design and the components of each layer. The base layer is known as the common knowledge base. This layer is designed to maximize security and decentralization and is the trust anchor for the entire network. This trust anchor is only possible due to a global, distributed consensus. The name of this consensus model on Nervos is NC-Max, and this video will explain why NC-Max represents the best iteration of current consensus models. In the original Bitcoin white paper of 2008, Satoshi Nakamoto explains how different participants on a network could all come to an agreement on the inclusion of transactions that are submitted to it. This process involves specialized machines, or miners, to undertake intensive computational effort to solve complicated cryptographic puzzles. These miners essentially compete with each other to find the correct solution to the puzzle so that they may broadcast the next group of transactions, known as a block, to the network and receive a reward for that computational work. These blocks, when linked together, are known as the blockchain. In order to avoid competing versions of the blockchain, the network always builds on the longest chain, or the most proof of work, as this is the most established. Furthermore, the inclusion of a difficulty adjustment ensures that the blocks are produced at an expected rate no matter how many miners are participating. This protocol, called Nakamoto Consensus, forms the backbone of Bitcoin's proof-of-work consensus model and has shown exceptional security and resistance to manipulation since its inception. However, it is not without its drawbacks. Long transaction confirmation times and limited throughput creates limitations for users. Nervos Network arose out of a need to address some of the prevailing issues facing pre-existing blockchain ecosystems in order to realistically become a foundation in the decentralized economy of the future. A team of researchers, led by Ren Zhang, investigated all variations of proof-of-work and proof-of-stake. They concluded that the non-proof-of-work models introduced new security assumptions and uncertainties, and that Nakamoto Consensus combined simplicity with time-tested robustness, resilience to manipulation, and reliability. But in order to maximize its performance, as well as eliminate some of the drawbacks, a modified version was proposed, NC-Max. NC-Max is a well-published, peer-reviewed consensus model that advances the original Nakamoto consensus model by introducing some important changes. First, transaction confirmation follows a two-step process, propose and commit. As compared to Nakamoto Consensus, this innovation reduces the problem of transactions not having been fully propagated across the network, thereby causing delays in block verification by other miners. Transactions now have more time to spread to all nodes without creating a bottleneck or slowing down the network. Secondly, NC-Max enables dynamic block time. As opposed to Nakamoto Consensus, where one block is generated every 10 minutes, NC-Max regularly adjusts the rate of block production to improve overall throughput. With faster block times, transactions can be confirmed quicker, but a consequence of this is the creation of orphan blocks, which occur when the network isn't fully in sync and is inevitable on a decentralized network. Such blocks are ultimately not confirmed. In order to stop too many orphan blocks occurring, NC-Max automatically adjusts by slowing down block times as necessary. The overall result is increased throughput compared to Nakamoto Consensus, whilst still maintaining overall network reliability. Thirdly, NC-Max takes extra steps to ensure selfish mining attacks are unprofitable. Selfish mining is where miners can unfairly gain a greater share of rewards whilst contributing less hash power to the network. It occurs when a miner secretly withholds a discovered block in order to orphan the honest block of another miner. This has the effect of lowering difficulty and increasing rewards at the expense of the miner who had their block orphaned. NC-Max ensures that this attack is unprofitable in all circumstances by considering all blocks, even orphans, when adjusting the difficulty of the network. These improvements have been well researched and presented at many of the most renowned global security conferences. This shows a meticulous attention to detail from Ren Zhang and his team in upgrading Nakamoto Consensus without introducing new flaws. In order to provide trust and security to the entire network, NC-Max builds on the tried and tested industry standard first introduced by Bitcoin, and it does so whilst also reducing bottlenecks, improving transaction throughput, and eliminating selfish mining attacks. Not only does this make the common knowledge base a reliable settlement layer, it enables it to truly embody the principles of censorship resistance, decentralization, and permissionless participation. With Nervos, everyone wins.